Alright, let's work through some problems together. So first one says, Amir said the expression log base 5 of negative 25 simplifies to negative 2. Explained his possible error. Oh yeah, there's an error, alright. The error is that, as I warned you about in the last video, 5 to the negative 2 power does not equal negative 25. It equals 1 over 25. That's important to remember as we go through this journey of logarithms together, that negative exponents don't make negative numbers, negative exponents make fractions. Let's write that down just for funnies. Negative exponents do not make negative numbers. Negative exponents make fractions. And then you have to keep in mind that if you have already a fraction and you raise it to a negative power, then the negative and the fraction cancel each other out and you get a regular number. So that's fun. Alright, so now we're just doing some simple rewriting in logarithmic form. So number 5, we're going to rewrite this as log base 2, because the base of the exponent becomes the base of the log, and then these two numbers get switched. So it's log base 2 of 1 over 64 equals negative 6. And so this is an example of the property we're just talking about. 2 to the negative 6 is not negative 64, it's 1 over 64. Okay, next one. So this time the base is e. So as we talked about at the end of the video, that means the notes, that means that we're going to use natural log instead of log. So I don't need to write the e. I could, but I don't have to, so I ain't gonna. Natural log of 54.6 equals 4. So there's a hidden assumed base in there, which is e. We don't need to write that. Okay, now we're going the other way around. So we have things that are already logs and we're writing them as exponents. So remember that if there is no base written for a log function, then we assume that that base is 10. So this would be rewritten as 10 to the 2.301 equals 200. And for Visa 1, since this is a natural log, that means the base is e, so I'm going to say e to the 3.22 is equal to 25. So this number down here, 10, to this power, 2.301, equals that number there. Excuse me, this number here to this power equals this number here. Alright, so now let's evaluate some. So number 9 is a very simple question. It's just saying 4 to what power is 64? So that would be 4 times 4 times 4 equals 64. So that means that 4 to the third equals 64. So the answer is 3. Number 10, same deal. There's no base written here, so we're going to assume that it's 10. So I know that 10 times 10 equals 100, which means that 10 squared equals 100, which means that 10 to the, wait for it, negative 2 power equals 1 over 100. So the answer to this one would be negative 2. Negative exponents make fractions. Alright, use the graph of y equals 3 to the x to estimate the value of log base 3 of 50. Okay, so this graph shows various powers of 3. 3 to the 0 is 1. 3 squared is 9. 3 to the third is 27, and 3 to the fourth is 81. So if we're trying to figure out the value of log base 3 of 50, what we're being asked is to figure out what power I would have to raise 3 to get 50 as an answer. So if I look at the graph here, get 50, that looks like it's going to be, hard to read that. Oh, this is 3.5, I don't know, maybe about 3.6. And the reason for that is that if I go to this point right here, that's telling me that if I plug in 3.6, 3 to the 3.6, then I get 50 as an answer. So I can see that from the graph. That's disgusting. So this point right here is, I'm guessing, 3.6 comma 50, which again means that 3 to the 3.6 equals 50, so in that case x equals 3.6. Okay, the student says that log base 3 of 1 over 27 simplifies to negative 3. Is the student correct? In this case, yes, because 3 to the third power equals 27, so 3 to the negative third power, 3 to the negative third power would then equal 1 over 27. Oh, come on, man. Get it together, Aldrich. 1 over 27. Okay, so yeah, in that case, that is the correct answer. That. Alright. Why is the expression natural log of 1,000 not equal to 3? Well, log of 1,000 equals 3 for the simple reason that 10 to the third equals 1,000. However, natural log of 1,000 does not. I bet I have a does not equal symbol up here. What do you guys think? Go to the math section. And sure enough, there she is. However, natural log of 1,000 does not equal 3 because, remember, for natural log, the base is e. So e to the third does not equal 1,000. Okay. Alright, what do we got going here? Oh, 31 through 38. Alright, so we're into the heart of it now. Alright, so evaluate each of these log expressions and then we are donezo for the day. Alright, so these will be quick and easy. So number 31 is asking 5 to the what power is 125. Well, I know 5 to the third is equal to 125, so that means 5 to the negative third is 1 over 125, so that's what I'm going with. 32, 6 to the what power is negative 216. That has no solution because there's no power I can raise 6 to and get a negative number as an answer. Okay, log base 3 of 3 equals 4. We have discussed this already. If this number and this number are the same, then basically those things cancel. And so the answer to that would be 4. Okay, next one, 33. 2 to the what power is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means it's 2 to the 5th, so the answer to that one is 5. Oh, that was 34. Okay. 35 says log base 9 of 729. So 9, how many times do I have to multiply 9 by itself to get 729? 9 times 9 is 81. Times 9 is 729. So that means 9 to the third. So 3 is my answer there. Number 36. I know that 8 squared is 64. So 8 to the negative 2 is 1 over 64. 37. 7 to the what power is 0? That's nothing. Don't get confused. 7 to the 0 power is 1, but there's no way I can raise 7 to a power and get 0 as an answer. And then finally for 38, this is the general case of this one that I was showing you a second ago. Since the base and the base are the same, they're going to cancel out. And so the answer to that is A. That's all we're left with. Okay. All right. So that's logarithms in a nutshell. If you didn't think that was a good time, then you obviously don't know how to have fun. Tomorrow we will talk more about logarithms. So if that doesn't get you out of bed in the morning, I don't know what will. All right. See you then. Bye.